Hey guys! So, for the last episode of A Gal's Guide to the Ocean, your host, Catherine, will be doing the intro this time, and we have here our other host,
JD.
And for the special events, we will be introducing our editor. Yeah! Say your name.
Juan.
Good job, editor. So, today we will be covering SLO 3, as which I said, and the topic will be waves. So, to introduce waves, we need to know the basic parts of a wave. And one may think that there isn't much to a wave, but there's actually multiple components to it. These components are still water level, which is where the water surface would be if there were no waves. It would basically just be calm water, like just still, as the title says. The next component is crest, and this is the highest point of the wave. And true, I think is how you say it, is the lowest point. The next component is wave height, and it's the distance between. Sorry for the interruption. Wave height is the distance between the crest and the trough. And wavelength is the distance between the identical points on the successive waves, like crest to crest. And finally, the last component is the wave steepness, which is the ratio of wave height to length. When it exceeds 1/7, the wave gets steep and will break.
Okay, for this SLO, I will be talking about knowing some of the terminology used to describe the motion of a wave. And so there's basically three words, and those are period, frequency, and speed. And they're fairly simple, and things that we've definitely heard before, maybe used in math sometimes, or like anything to do with science, really, so like chemistry or physics. And so the first one for period, this is basically the time it takes for two successive crests to pass a specific point. And so now frequency is the number of waves passing a point in a certain amount of time. And this is also known as like waves per second. And this is also the inverse of what period means. And for the last one is speed, which is, of course, how the wave travels, or like the distance traveled per unit of time. And it's also called celerity. And this later turns on into an equation that you can use to like calculate and guesstimate and infer. But yeah.
Okay, so now I will be discussing the difference between deep water waves and shallow waves. Deep water waves is when the water below a wave is deeper than the wave base. These waves experience no interference from the bottom because the water is deeper than the wave base, which I just explained. This means their speed solely depends on the wavelength. Shallow water waves is when the depth is less than 1/20th of the wavelength. The waves basically touch bottom due to the depth being shallower than the wave base. And this basically means the orbital motion is affected by the seafloor. The speed of shallow water waves depends on the depth.
Okay, so to continue, I'm going to be also talking about understanding what causes tsunamis and how they behave in the ocean. And this is really interesting because I've always found tsunamis interesting in general.
And scary.
And scary, and I feel like everyone thinks tsunami, end of the world, and no one really pays attention to how they happen. And so that's what I'm here to talk to you about. So the first thing we should talk about is the misconception. Tsunamis have nothing to do with tides, and they are not tidal waves. They are actually their own, phenomenon. And so they're actually large waves, and they're usually the result of seismic activity. And so that's just basically relevant to the rising and falling of the seafloor because of the earthquakes. And so this all ties back to tectonic plates, which I believe we have discussed in one of our other podcasts, which you should definitely take a look at. But also they can happen because of volcanic activity, landslides, and like I said, anything relevant to tectonic plates, because earthquakes and landslides, they all literally have the I believe it's converging and diverging. So definitely take a look at that. Very important. So anyways, as the seafloor rises and falls, um so does the water column above it, creating the waves. And another important fact is that only vertical seismic disturbances cause tsunamis, not horizontal. That's another common misconception. So vertical movements are like less than 10 meters, I believe. 10 meters high, and so since they have kind of a small height at their point of origin, they have long wavelengths, and so this ends up behaving as shallow water waves through the entire ocean. And so this is how it behaves and reacts in the ocean. So the depth of the ocean is always kind of more shallower than half of their wavelength, which is actually pretty interesting because um not necessarily how it's depicted in movies sometimes, right? Like you don't see what's happening behind the scenes or how it's even forming. So just some food for thought.
Okay, so for the last objective of this podcast, I will be talking about the factors that influence wave speed. The factors that influence wave speed is wind speed, the duration of the wind, and the distance over which the wind blows across the water on the same direction. The increasement of any of these factors will also increase the wind energy, which results in size and speed also being increased. These waves will receive the energy, which results in the water. No, which results in then getting larger and steeper. However, when the wave height exceeds 1/7 of wavelength width, which I just explained in another objective. So when it exceeds this, the wave will be unstable and collapse. So that's all I have to talk about the factors. And this results in our outro, which is the last episode.
The end.
Oh my goodness. It has been an absolute pleasure being one of your hosts.
It hasn't.
And I really appreciated this opportunity to speak and teach you guys what I learned in oceanography, and it has been an absolute ride.
Yes, both good and the bad. But now we will say our goodbyes. This has been it with your host, Catherine.
And JD.
And our producer,
One.
Bye.